Last time we have discussed about this DBA. Last time we have discussed about the reaction of dibenzoyl acetylene COC6H5 acetylene bond COC6H5. This is called dibenzoyl, just abbreviated at 1 to dibenzoyl acetylene. So and then we looked into the reaction of this is a highly it acts as a very good dienophile because of the presence of two electron withdrawing group on the acetylene bond, just like DMAD, dimethyl acetylene dicarboxylate. So this is also a very good nucleophile and add to anthracene in a 4+2 manner. So here this is the 9-10 bond, 9-10 position of the anthracene ring, and it has been found that this diene of anthracene the reacts with the acetylene to give you 4+2 under thermal condition and give 4+2 cycloaddition reaction, and a series of different substituted R1 and R2 disubstituted 9-10 anthracene has been studied. The reaction of a variety of 9-10 disubstituted anthracene with the dibenzoyl acetylene have been carried out to give a corresponding 9-10 added product, and the subsequent reaction of these dibenzoyl anthracene adduct have been studied. So we have looked a large number of reactions of this type. Now we will see how dibenzoyl acetylene can also act as a the reaction of dibenzoyl acetylene with several nitrogen heterocycles. The nitrogen addition of nitrogen heterocycles with dibenzoyl acetylene have been studied. For example, if we have a say nitrogen heterocycles like indole, like this, it can there is a H here. The lone pair of this can add to one of the acetylene bond, and then so the N substituted dibenzoyl ethylene gives rise to N substituted nitrogen. So a large number of reactions of nucleophilic reaction of N heterocyclic system with dibenzoyl acetylene has been studied, and then we will look in few reactions of this type. So here is an example. This is a benzimidazole. This is a 5-membered ring, a 6-membered ring. This is a benzimidazole with a substituent R. R is also a phenyl group. So it is a 1, 2, 3. 1, 3 position is a nitrogen, and then there is a connected to a benzene ring. So benzimidazole, 2-phenyl benzimidazole reacts with dibenzoyl acetylene. This is dibenzoyl acetylene. One benzoyl group, another benzoyl group connected to acetylene ring. When it is refluxed in acetonitrile for few hours, it can add in a nucleophilic manner. Lone pair of this nitrogen can add to one of the carbon of acetylene bond, giving rise to an anionic species. In fact, it goes like this, and then it comes back, and then so when it adds like this. Say nitrogen goes like this, and then and then another another double bond, and then the O minus, and then C6H5, and then this comes back and abstract a proton from this. So it gives a N substituted benzimidazole dibenzoyl. N substituted dibenzoyl imidazole derivative have been reported. This is a Z isomer. This is a one benzoyl group and another one benzoyl group side, and this is the E isomer, or we call it as a so E and Z isomer. So this is possible that both the benzoyl group can be once in cis orientation. Is also possible that two benzoyl groups goes in a trans manner. So benzimidazole acts in a the benzimidazole acts in a nucleophilic manner, giving rise to attack of the lone pair of this nitrogen to one of the acetylene bond, and followed by abstraction of a proton, and proton shift from here to here gives rise to the ethylene linkage. So it is a N-benzoyl and N-dibenzoyl benzimidazole, two isomers E and Z. E and Z, where two benzoyl groups are on the same side and the other two benzoyl group on the different side, or we call it as a E and Z isomer, is a mixture of, and depending upon the, it has been found that the yield of formation of E is much higher as compared to Z because of the steric hindrance between the benzoyl group here and the phenyl group over here. But anyhow, we get a mixture of these two products. So benzimidazole undergo nucleophilic addition of one of the nitrogen of the imidazole ring, acts to the in a nucleophilic manner at one of the acetylene carbon, followed by abstraction of proton, gives rise to dibenzoyl ethylene added to the benzimidazole. It gives a mixture of two products, and the E and Z isomer, and then the yield of this this isomer is higher, whereas this is found in less amount because of the steric hindrance between the R substituent as well as benzoyl group. The structure of these two isomers, the E and Z isomers, have been well established not only by spectral analysis such as IR, proton NMR, C13 mass, but also by single crystal X-ray analysis. And here is a structure of single crystal structure of both the isomers, these benzoyl groups on the cis orientation, two benzoyl groups on the trans orientation. So if you, this is the single crystal X-ray structure of these two E and NZ isomers. Here we can see this is the benzimidazole ring. This is benzimidazole ring here, and this is 6 and 5. These are the two nitrogens, 1, 2, 3 position, 2 nitrogens are there, and there is the at carbon number 7 in the middle of this carbon, which is between the two nitrogens, there is a phenyl group, as here this is R is equal to C6H5. R is equal to C6H5. So it's phenyl group, and then the two benzoyl groups. See, this is ethylene. This is the carbon-carbon double bond. This is the this carbon-carbon double bond here. Carbon-carbon double bond. There is a benzoyl group, carbonyl, and then phenyl. So one benzoyl group over here. There is another benzoyl group here. Both are in the cis orientation, and this is ethylene. So this is the single crystal X-ray of this is well established, and this is the structure is beyond doubt, not only by spelling acid, but single crystal X-ray structure is a well and ambiguously confirmed. This is the X-ray structure of the trans isomer, where the two benzoyl groups are on the opposite side. This is the imidazole ring. This is imidazole ring over here. This is a 6 benzene ring and a 5-member ring. Nitrogen 1 and 3 position is a nitrogen. This is a carbon. There is a phenyl group. This one R is equal to C6H5. So there is a phenyl group in the carbon between the two nitrogen and the two. This is the ethylene. This is the ethylene bond. This one, and then the one benzoyl group on the this side of the ethylene bond, another benzoyl group on the opposite side. So this is the trans. The other isomer of the dibenzoyl acetylene added benzimidazole adduct. The structure has been well confirmed by single crystal X-ray. So just to summarize this, the imidazole acts in a nucleophilic manner to dibenzoyl acetylene, giving rise to two adducts, cis E and Z, and the structure of both the adducts have been confirmed by single crystal X-ray as shown over here. The yield of the product of the isomer where the two benzoyl group on the same side is higher as compared to the yield of the product on the isomer where the two benzoyl groups on the opposite side, because of the steric hindrance between the substituent at the carbon R, which is a phenyl group, is also quite bulkier group, and of course benzoyl group itself is a. So if you look at this, it will be like this, the one benzoyl group, and then here it is really it is a very highly crowded, and hence, but still there is a possibility of formation of the trans isomer as confirmed by single crystal X-ray. The only thing is that molecule is a single bond can orient and take care of the steric hindrance to some extent. The photochemistry of these two adducts, the photochemistry of E and Z isomer of the dibenzoyl added products have been well studied, and results are shown over here. So of course this reaction, what we have shown, R is equal to C6H5, but to generalize this, a large number of derivatives of the imidazole derivative, where R1 and R2 can be of different substituent. R1, R2, R3 is C6H5 as we have seen in the first one, but these four are additional substituent where the so it is a very extensive study of the nucleophilic addition of a large number of imidazole, where these substituents R1, R2, R3 are these A to E can add into dibenzoyl acetylene in the presence of estronitrile under refluxing condition 8 to 10 hours. It gives rise to two isomer E, two benzoyl groups on the same side, and two benzoyl groups on the same side, and the other isomer where the two benzoyl groups on the E and Z isomers, E and Z mixture of E and Z added product of large number of imidazole have been reported, and we can see here as mentioned before, the yields of the isomer where two benzoyl groups are on the same side are much higher as compared to the two benzoyl groups on the opposite side, because of the severe steric hindrance between the benzoyl group as well as the substituent R over here. The benzimidazole adds to dibenzoyl acetylene in a very generalized manner through a nucleophilic attack of the lone pair of nitrogen to one of the acetylene carbon, followed by abstraction of a proton, giving rise to dibenzoyl acetylene adduct 3 and 4, and it has been structure has been well studied, and the reaction have not only with one substituent, with a large number of different substituents have been studied. The photochemistry of these two adducts have also been investigated by George and co-workers at IIT Kanpur, and this is the work done by Dr. Laurie at IIT Kanpur, and this is a very interesting photochemistry, and we can say that this is the photochemistry of the adduct, dibenzoyl imidazole adduct, imidazole DBA adduct, DBA, dibenzoyl acetylene imidazole adduct, whether the two benzoyl groups are on the same side. We can see the photochemistry of a large number of derivatives of this dibenzoyl acetylene have been studied. HNU in the presence of benzene or methanol. The photochemistry has been studied both in the benzene as well as methanol, and it undergoes different pathways are available over here. See, when R2 and R3 are the phenyl group, diphenyl. When you have R2 is a phenyl group, and the R3 is also a phenyl group. Of course, this is R2 and R3. Then this is under photolytic condition. These two phenyl groups are nicely set for 6 pi electron cyclization, 2, 4 and 6. So 6 pi electron cyclization giving rise to dihydrophenanthine derivative, and then this is the photochemistry, and then it gets very fast aromatization to give the phenanthine derivative under very mild conditions. But the main photoproduct is dihydrophenanthine derivative, which is observed when R2 and R3 is a diphenyl group. Under fertility condition undergoes 2, 4, 6 pi electron cyclization to give this, and this 6 pi electron cyclization we have already seen earlier during the photochemistry of E and Z alkene as well. So here this type of products are formed when R1 is equal to CCH5 and R1 is equal to also H. So dihydrophenanthine derivative is, I mean this this substituent CCH5 or H, in both the cases this gives dihydrophenanthine. Very interesting product in the sense that we start with just a simple imidazole, diphenyl subimidazole. We are ending up with polynuclear aromatic hydrocarbons after aromatization give this synthetically very important. Other photochemistry, this is a path A which is observed 6 pi electron cyclization photochemistry. Other path A is observed is the when R is equal to C6H5 R1. R1 is equal to C6H5 here, and of course R2 and R3 is equal to these substituent. So when it is a phenyl group, when the R1 is a phenyl group, so this is also nicely undergo 2, 4, 6 pi electron cyclization by involving 1 pi bond of benzene ring, 2 lone pair electron of nitrogen, 1 double bond of the ethylene, I mean the bond here from the dibenzoyl alkene part, and then it also undergoes cyclized product, the nitrogen containing heterocyclic system, and this is also a very interesting photoproduct observed in these reactions, imidazole dibenzoyl alkene adduct, where when R1 is equal to phenyl group, the participation of lone pair of electron, 2 electrons from this to 1 pi bond of this, 1 pi bond undergoes 6 pi electron cyclization to give this nitrogen the 5, 6, 6 dihydro derivative, and then other the third, this is path A and this is path B, and third pathway which is open is just a cleavage, of this bond. So this undergoes cleavage to give you dibenzoyl alkene part and then imidazole part. This is also observed in the photochemistry of this, and other this is the path A, and this is path B, and this is path C, where the just cleavage of the linkage between the imidazole nitrogen and dibenzoyl ethylene bond cleavage. The path D, path D is the dibenzoyl alkene rearrangement. See, this rearrangement we have already looked into while studying the photochemistry of alkene. When we have what we have learned earlier, that when we have a 2 benzoyl group in cis orientation, the excited state of the carbonyl adds to phenyl group and then gives a 6-member intermediate, and there is a possibility of migration of phenyl group to this formation of a ketene derivative, and then the ketene is converted to an ester. This is an ester, and then this is the phenyl group which is migrated from this bond. So it is a phenyl migrated, is called dibenzoyl alkene rearrangement, and this is an ester moiety which is formed the intermediate which is the ketene intermediate, which in the presence of methanol is the solvent. It gives an ester in all. So this product is very prominent in all these substituents such as DE and 10 as well as 11 this one. So we can say that the photochemistry of dibenzoyl alkene, imidazole dibenzoyl alkene is well studied, and it gives a very interesting photochemistry. 4 different pathways. Path A is the 6 pi electron cyclization to benzene ring of the imidazole accept, and the benzene ring which is present in the imidazole ring to give a phenanthrene type derivative. The other pathway is the when arvin is group phenyl group, then it undergoes also the 6 pi electron cyclization via the incorporation of 2 lone pair of nitrogen, 1 double bond, another double bond of phenyl group. So 6 pi electron cyclization to give this. This is the second photo product. So very nice as the added and the third pathway is the cleavage of this imidazole ring and the dibenzoyl alkene, and the fourth pathway is the dibenzoyl alkene rearrangement where the excited carbonyl adds to the benzene of the other carbonyl, and then the formation of a 6-member transition state, and then migration of the phenyl group to this, as we can see, O6CH5, and this goes as a ketene, and then which in the presence of solvent gives to ester. So this dibenzoyl alkene rearrangement we have already seen in the initial periods when we have discussed the photochemistry of alkene derivative. So this is very interesting. The reaction, the dibenzoyl acetylene adds to imidazole in a nucleophilic fashion, giving rise to ENZ isomer. ENZ isomers structure have been well confirmed by single crystal X-ray. The yields of the the isomer where the 2 benzoyl go on same site are much higher as compared to other one because of the steric hindrance between the benzoyl group and the substituent present as R1. The photochemistry is very extensively studied, which gives 4 different pathways. Path A is the 4 different photochemical pathway. First is the photochemical 6 pi electron cyclization of 2 phenyl group to give this dihydrophenanthrene, which aromatizes to give phenanthrene derivative. Second is the when CCH5 is the R1 is equal to CCH5, then undergoes 6 pi electron cyclization to give this tricyclic 5-6-6 with the containing a nitrogen as a heterocyclic system can be performed. Third pathway is the cleavage of this bond giving imidazole and this, and fourth pathway is the dibenzoyl alkene rearrangement where the phenyl group is migrated to the other benzoyl group to giving rise to an ester derivative. So coming to the not only the imidazole, this reaction was well further extended, and the not only the pyrazole derivatives have also been studied, and this is a large number of pyrazole derivatives with different R1, R2 and R3 substituent are shown over here. Also adds in a similar fashion, the lone pair of nitrogen adds in a nucleophilic fashion to one of the acetylene carbon followed by abstraction of a proton. This is the intermediate, and then it comes back and abstracts a proton to give this intermediate, and then ultimately what we get is the 2 products, the 1 benzoyl group of both the benzoyl group on the same side, and both the benzoyl groups on the trans side. So essentially is a similar type of product which we have seen in the case of imidazole. The pyrazole derivative, a large number of pyrazole derivatives where A to E with different substituent R1, R2 and R3 has been have been known to add to the dibenzoyl acetylene. So you can see that dibenzoyl acetylene acts as a very good nucleophile. And it can acts as a very nicely add nitrogen can add to this acetylene to give rise to nucleophilic addition product, and not only that, it also acts as a dinophile to give a Diels-Alder adduct. So in addition to imidazole, pyrazole also gives these similar type of ENZ isomer, and in all the derivatives, and the structure of these have also been well studied by spectral analysis such as proton NMR, C13 mass, and so on and so forth. The furthermore extended reaction of these the nitrogen addition of the nitrogen heterocycle with dibenzoyl estenes have also been carried out. You can see it is the 2-amino benzothiazole, 2-amino thiazole, 2-amino benzothiazole can add in a dibenzoyl acetylene in a nucleophilic fashion. The lone pair of nitrogen can add to this, and then it has been found that it is not only the giving the nucleic, but it is also giving a tricyclic system. This anion which is generated here can be participated to this then other nitrogen which is present in the imidazole ring. So it gives a tricyclic 6-5-5 ring system. The benzoyl group adds in the participation of a cyclic system in the. So if we start with a properly substituted nitrogen heterocycle derivative such as 2-amino benzothiazole derivative and reacts in the presence of benzene, reacts with acetylene and in a nucleophilic. This is the first step. Anion which is generated may participate in the formation of cyclic product as shown over here. So the structure of this is also well established by not only by single crystal X-ray, not only by spectral analysis, but also by single crystal X-ray analysis. The single crystal X-ray structure of this is shown over here. This is the adduct, the cyclized product of the 2-amino benzothiazole with reaction with dibenzoyl acetylene, giving rise to a cyclized product. This is benzene ring, 6-membered ring. This is a benzene ring. This is a imidazole ring, a 5-membered ring, imidazole, nitrogen and sulfur here, and then there is another nitrogen with a double bond. This is a OH group over here, the phenyl group here, and then of course with the ethylene linkage, and then of course is the benzoyl group. So the structure of this cyclized product from the 2-amino benzothiazole is well established by single crystal X-ray analysis, and the reaction of this the diphenyl imidazole has also been carried out with DBA in the presence of triphenyl phosphine. Triphenyl phosphine is an acid catalyzed reaction. Forms a complex with the carbonyl and facilitate the reaction. It's a very interesting reaction has been observed. What we have seen in the absence of, when we do the reaction by refluxing these two in benzene and methanol, we end up with a nucleophilic addition to this, giving us to E and Z isomer. But when the reaction of this imidazole with acetylene was carried out in the presence of triphenyl phosphine derivative, which is a acid catalyzed reaction, promotes the cyclization reaction, and it gives a very interesting furan linkage involving the reaction of this oxygen with these acetylene beings, which is diphenyl furan cyclized product with the linkage with the in connecting with the imidazole has also been reported when the reaction of these two derivative was carried out in the presence of triphenyl phosphine. So we see a different reaction when triphenyl phosphine is used as a catalyst which catalyzes the reaction, initiate the cyclization of this part, whereas the imidazole parts remain as it is attached to the. So this undergoes cyclization with the initiated by the triphenyl phosphine. I'm not going into the detail of the mechanism, but just say that these reactions had been well explored to give rise to synthetically important products. As we can see, we get the furan, diphenyl furan, 2,5 diphenyl furan ring system, and the structure of this is well confirmed by single crystal X-ray. We can see here, this is the imidazole ring, a 5-membered ring, one nitrogen, another nitrogen, a 5-membered ring. The two phenyl groups, this is a phenyl group as shown over here. This is a the nitrogen is a these two phenyl groups of this 3, and this is the furan ring, 5-membered ring with a carbon with a oxygen in the linkage. So 1, 2, 3, 4, 5. A 5-member furan is shown here, 2 phenyl group. The structure of this cyclized product, which is formed in the presence of triphenylphosphine on the reaction of imidazole with dibenzoyl, has also been well confirmed as a different type of reaction, as we have seen in the earlier cases, where in the absence of this, imidazole acts in a nucleophilic fashion, giving rise to E and Z adducts and of course the photochemistry. So this is all for today, and thank you very much. We'll continue.